All right, today we're going to be going over a method that creates the most durable connection between 3D printed pieces and the best way to cover seams in your 3D printed props. A method we should strive to start moving away from is using some sort of glue like a contact cement and bondo spot putty to cover the connection. Prints are starting to have very small ways to connect them, so there's very small surface for the glue to connect to and create a strong connection. The other thing is glues typically are flexible, so it's going to allow a lot of flexing in your connection, meaning it's going to be brittle and eventually break the seam you're trying to cover and show cracks. The other thing is this bondo spot putty is, when it dries, it's like a clay, which is a very brittle substance, so this flexing is going to break this and you'll start to see cracks. But also, this is a different material than plastic, meaning these two items are going to have two different expanding and contraction points with temperature. So this is actually getting micro cracks just with the change in temperature, meaning our goal should be to have a connection that is just one material or just a different material than this glazing spot putty. That's why I recommend using a plastic welder. All right, so what a plastic welder does is, all it does is it heats up this little tiny staple and makes it red hot. And once you got it red hot, you can actually press it into your connection, and it's going to melt the plastic around her, so this can be inserted into the surface. While this does seem kind of small, have you ever tried to rip a paperclip apart? The tensile strength of metal is extremely high, so without bending it, you're not going to be able to break it, which makes a lot stronger connection than any glue could ever do. But also, since it's metal, it's not going to flex around and cause that crack to form in our seam. Now, before we get started, we do need some PPE. I recommend gloves if you need them. I do recommend a respirator. The 6923 respirator is pretty good. I also recommend some safety glasses, but one thing is I recommend a fan. If you have the fan pointed towards the where the fumes are being generated, it's actually going to blow the fumes away from you, and they don't even reach your respirator, which adds another layer of protection for your lungs. All right, so when it comes to prepping your 3D print for this plastic welding, there's two things you need to do. One, you need to file it down to make sure that the connection is as flush as it can be. But the other thing is too, when you need to go into your slicer and on the part you're going to connect, the rest of it can be whatever kind of infill you want, but I would say about a ½ inch from where you're going to connect it. That little ½ inch area needs to be 100% infill. By doing this, it gives us some sort of plastic to actually melt into, because if this was hollow right here, this heated staple is just going to go right through it, and there's not going to be anything to hold it together. So, as you can see, there's not much you really need to have 100%, but definitely don't skip that part. All right, so now that everything's flush, it's 100% infill, I'm going to go ahead and I'm going to plastic weld this together. What you're going to want to do is make sure everything, kind of press it together so it stays flush. You're going to go ahead and press a trigger on this. That way it's going to heat up outside the print. Once it's red hot, we're going to hold the trigger the whole time and push it into the connection. Once we get the staple fully covered, that's when we can let go of this, let it cool down for a second, and we can actually pull this out. All right, so I'm going to hold the trigger. You're going to notice this thing's getting red hot. I'm going to press this in, holding the trigger the whole way. I'm going to get a little bit in there. I'm going to let off the trigger once I reach the desired depth. I'm going to let it cool down for a second, so that way I don't pull the staple out. And once it's cooled down, I'm going to go ahead and pull it out. All right. So notice that the little waves on the staple are equally covering the seam. It's not over the top or anything or one way. And it's going to look like this. Whoops. I'll try to focus it, but it's going to look like this. It is going to push some plastic up, that's fine. It's going to help us in the next step, but you're going to go ahead and do this around the whole item. And then we're going to go to the next step right after that. All right. So now that you have the plastic staples all the way around the surface trying to connect, we're going to go ahead and get some sort of clippers and cut off these little metal pieces that are sticking up. Usually the plastic welder comes with these. And obviously you want to get this as flush as you can to the surface. Just as simple as that. They do kind of fly pretty far, so I don't know, maybe you want your hand to cover it. But yeah, you're just going to do that all the way around. All right. So now with all those little bits chopped off, we are left with this. However, you will notice that there's some metal parts sticking out that are not flush with the surface we're trying to create. You're going to have to end up filing those down. So you can either use a file, or I actually recommend a Dremel tool. It makes it a lot quicker because we're trying to remove a lot of material. Your goal is to make that little point lower than the surface you're trying to create. And by making it lower than the surface we're trying to create, we can cover it with plastic so you don't see the metal bit sticking out. And also when it comes, so that's why I recommend using a Dremel bit that has a point to it, not like a flat one. And also you can get like a whole bag of these for pretty cheap. I believe these are the aluminum oxide tips, just something that's very hard, that's for grinding. So I'm going to do this part off screen because it does take a second. So I'll be right back. Okay, so now that we got everything sanded down, and let me zoom in here for you. Now if you see, I kind of made, you could call it like a crater, well, disregard these, but you can see I kind of made it like a crater. I wanted to make sure that the metal is below the surface we're trying to create. So whatever plastic you get rid of, we will end up putting it back. So don't worry about, going a little bit below the surface when sanding this. All right. Well, now that the item is connected, and you can see here, I'm literally trying to move this thing, twist it, move it, all that good stuff. It's not budging at all. Zero flex, meaning this is a very strong connection that our plastic welding has created. But now that we have a strong connection, now it's time to cover it. Instead of using a different substance, why don't we just use the plastic itself? That's why I recommend using a wood burning tool. A wood burning tool will just heat it up just enough so you can kind of smear the plastic over it. We're going to go ahead and demonstrate that here, but let's just say you're smearing it and you run out of plastic or something's not working. You can just go ahead and take the roll of plastic you used to print this, take the end of it, and you can just kind of solder the plastic on there if you are missing some plastic, so you can add plastic to it. All right, I'm going to go ahead and try to smooth this out. Let's see here. You see I'm actually covering the seam. Don't worry about this discoloration in the plastic. It will be covered up when you paint it. I think we might be able to get away with not adding any sort of plastic. Because if you notice, when we put the staple in, it actually pushed some plastic out to make room for the staple. We're actually using that to cover the seam. So might be good. Go ahead and finish this our side. I'm only doing like half of it just for demonstration, but you would do the whole thing. Okay, now here we might have to add some plastic. Yeah, we're gonna have to add some plastic because I went kind of far in just to make sure the staples are down. So what I'm gonna do is, you just put it right on there. Like you just have everything meet where you want to add the plastic. You're just gonna cut it off and just melt it on there. Simple as that. Make sure you're not hunched over top of this, sucking in all the fumes. You want to be away and have your fan blowing on this to blow all those fumes away from this section. And make sure you're in a relatively outdoor space that has a good airflow. All right, I think I'm liking this. Let's see here. Looks pretty good. Go ahead and just finish this one section. All right. with that. All right, so as you can see, there is no more seam here. The seam has been completely covered. Now, for the next step, what you want to do is you want to take your preferred method of sanding, and you want to make this whole surface nice and smooth. And you want to take a good amount of time in doing this, because this is the part that's either going to show up or not show up when you paint it next. So I'm going to go ahead, I'm going to use a Dremel tool in this case, and I'm going to go ahead and sand this down. Alright, so now I went and took a Dremel to this in order to remove a lot of plastic so it's nice and level. I would say with this top section right here, this is a good example of what you want. It is perfectly flat. There's no divots or any protrusions or anything. So ideally you want it like this. Let's just say you did take too much plastic off. You can always add it back by soldering on some more plastic. And you can always just add, remove until you get that perfect surface. Things you don't want is like this. There's still some lumps left. You can still see that metal bit right here kind of sticking out. You don't want that. Then on this side, you notice I went a little bit too far with a Dremel, so now I have this little valley. So I would actually go back and fill it up with plastic. But as you can see here, this perfect example on the top, perfectly flat, smooth. Connection doesn't move. There's no cracks going to form to expose this. And it is one piece with the plastic, because it is the plastic, meaning it's not going to crack over time. So there you have it. This durable print with no seams can be done. And as people store this on their shelves for years to come, you don't have to go back to it and fix it, unlike the bondo method. So with that being said, I hope this saves you a lot of time, and I hope your prints make it in the future nice and durable and will last a very long time.